Design almost always begins with a description of a need, okay? We need a better mousetrap. We need a two-person passenger vehicle for urban driving that gets the equivalent of 150 miles to the gallon. Somebody comes to us or you with a need and says, we really need to have this thing. The very first thing you should do as a designer is to stop yourself from solving the problem at that stage. Think of what it is that the object has to really do. Here's a very simple chart of most of the technical, scientific, engineering world, okay, including almost everything you've learned in school so far. Okay? You have something, a system or a device, and what you do is through a procedure called analysis, you establish how it behaves, what's its function. But if you think about where we started in that chart that I had up on the overhead a minute ago, it's exactly the opposite of this procedure. It says, gee, here's a behavior or a function we want. What can we design or synthesize, right, that has a desired behavior? It's exactly the opposite of what you've been doing so far in school. One of the things that this class is meant to do is give you enough experience that some of the most common beginner's mistakes about design are out of the way by the time you're done with this class. There aren't very many engineers who can go from not even knowing what the task is on September 30th to having a working device that accomplishes that task 9-10 weeks later, plus take 4 other courses and get A's. And, you know. This is an isometric, so sort of a 3/4 tilted view of the contest arena for this year. There's now a back wall, okay? Now the back wall has regions that are identified with different numbers, okay? Those are points, effectively. And this back wall is covered with Velcro. Now, what do you have to put up there? Well, you notice down on the table here, there are some triangles and 1 circle, 4 triangles, 4 squares, and 1 circle, okay? These are what we call scoreable items, okay? So the higher up a scoreable item is stuck on the wall, the greater the multiplication of its native value. So a cube stuck in zone 2 gets your team 2 points. Well, come on in, make room. There's plenty of room over there. Everything's set up for you right at this moment so you can see all the stuff that you're going to have available to you. The table, the back wall, the scoreable items, the rectangles painted, which the start zones, you know, the devices have to fit together inside there. Joysticks that control the power, all the power apparatus that's down below, timing apparatus, one example of which is over there. So it's all here exactly as it's going to be for the contest itself. There also are, as I hope you know from looking at the schedule, 2 design reviews. So we'll meet with you twice during the term, once only 2 weeks from now, and then another time 3 weeks from there, where we'll meet with you and talk about where you stand in your design, get you to show us what you're thinking about, and we'll give you feedback, critique, suggestions, all that stuff, okay, one-on-one, out of the hearing of everyone else. What do you think?
Looks hard. Looks really hard.
So what we're here today to do is to have you guys tell us a little bit about your design thinking and to show us what you've done so far. What have you got in mind?
One thing
So turn the drawings around and let me take a look at them.
Those are very interesting.
Those are really great drawings.
These pads.
Uh-huh.
The one that was kind of interesting but not very feasible was one where you use a bunch of sort of mouse ball-like spherical wheels so that the thing does not have to encounter this shearing problem.
The arm here is probably about maybe 2 feet long or so it can lean out and pick things up within its own range, but really can't get to the opponent's side too much.
And that is for if I can pick up the sphere in the beginning of some collection round.
Right. Okay.
It's going to go back there and sit
Just
there.
trap it.
The conveyor belt, you can back up to an object and roll it up on top, and then cruise around. And when you get where you want to go, you can roll it off onto the Velcro on the wall.
You drive up to the wall and this sticks.
Yeah.
And you roll up effectively this thing,
Yeah.
right?
Yeah.
Until the next one sticks and you keep going and it peels that one off.
Yeah. Exactly.
Be damned.
Okay, so I wanted to make something that would just, it would just automatically, just mechanically tell when it's up against the wall. And so the idea at this one is, if it drives up to the wall, it automatically goes up.
I want to cover their side of the wall with plastic, so that if anyone tries to drive up it, there's a strip across the bottom they basically can't.
So I can slip an item in here, and that'll close up.
When the thing turns, it'll pull this entire section back.
Very nice. Yeah.
His model works.
Yeah.
It doesn't quite go up that, but yeah, so it's supposed to go up and attach it and come down.
The first thing that I want to do is have these guns shoot some projectile out and just capture them all at the same time.
Why does your machine have 4 wheels?
I don't know.
Ah. Ladies.
Hello.
Good morning. It's fun to see when there's enough to carry that you need a box or a bag to carry.
I have things that look like this
Okay, well, let me look.
that are just, I screwed up transmissions
Yeah, okay.
and a couple of those.
No, try the other one, because this one I actually pushed a bit, a bushing in there. I can't decide which one I think is better.
Ooh, I like this one better.
I was thinking it was. It's just a little bit off, probably a thousandth or.
The only way that anything can slip in my entire drivetrain is for the belt to slip with respect to these pulleys, and that's not difficult to do. So what I'm thinking of doing is I'm thinking of making little, like, essentially like thumbtacks that stick out of the back of the drive one.
I was actually driving on these like about a couple of days ago, and it went up the wall somewhat.
Oh, okay.
And the problem I ran into is a couple of the holes wasn't press fit for some reason.
It works really well. I'll probably put another extension on the top, so it'll get even taller. And I still have to make the support structure for it, the slot for it to go on.
The motor alone probably can't start it, but with the help at the beginning, then I can at least get a little bit more speed.
Okay.
At a reasonable rate climb.
Okay.
It'll slide like that. And time permitting, I'm gonna add one more stage on the base.
The driven wheels will be in the front, so it can like get on the wall, and it's gonna hold like the squirrel items in this area.
The net is loop type Velcro.
Right.
In a big mass. It's just going to go out, and if you drive over it, you're toast.
Right, if you have hook Velcro on your
on
tires.
your wheels.
Yeah.
Yeah.
Good, okay.
Not good if you're in a pack.
No. Are you gonna make the wheels as wide as the Velcro?
No.
So the Velcro is gonna be wider than the wheels?
Yes.
Okay.
Because I don't really need more wheel. I mean, when I had it just with the Velcro half the thickness, it didn't climb.
Right.
When I did that, it solved the problem, so there's no need to add the weight.
I'm wondering if crawling on the wall is the right solution to this problem at all.
Right.
So,
well, I guess it's irresistible.
well, I mean, it's definitely
on the wall.
it's definitely the coolest solution to the problem.
Well, I don't know,
Whether-
flying might be the coolest
Well,
solution.
yes,
but
yes.
leaving practicality aside.
Right. But I'm not convinced it's practical any longer.
Well, you got 3 weeks left.
It takes so long though.
Oh, it does,
Like
I know.
you go and you think you can make this today, and stuff happens. No, you don't finish.
Absolutely.
Absolutely.
Absolutely. Well, you need to start here and show me that you meet the weight constraint. 2.6, okay, that's fine. Okay, now, your objective is to score a point, if you can. All right? Ready, set, go. Oh, look at that. Isn't that nice? Oh, look at that. Oh, that is wicked. Oh, yeah. By a thread. Don't bump him, don't bump him. Oh, yeah. Oh, very sweet. Oh, and you just ran out of power. Oh, funk. Oh, look at that, look at that. Whoa! I think that does it. Yep, right? Don't you agree?
Yeah, I'd see.
Starting right now, I'm not going to do this, but you need to relax. Okay? The work that you've done that contributes towards your grade is almost completely over. You know that Greg and I have been assessing your machines, looking at them. We spent a lot of time with them over the break. That's what counts towards your grade. What you do on Thursday, other than showing up, doesn't count towards your grade, right? It counts towards your own pride, your own showing off, your own having fun. That's what that event's for. Don't lose sight of that. Absolutely, the thing you should be doing at this point is practicing. If you have ideas for engineering improvements, it's probably time to forget them, and probably time to just concentrate on making sure that you know how to work the machine you have today. Remember, the contest isn't fair. It does choose people randomly, and so there is the chance that things will look unfair because it's chosen randomly, all right? Recognize it's not fair. It's not a round-robin tournament, and even if it was, that wouldn't be fair either. So it's not your performance, it's not the pairing, it's not who you get chosen against. It's an opportunity to show off how well your device works. Good afternoon, and welcome to the 15th annual ME72 Engineering Design Contest. I'm Eric Antonsen, and I'm delighted to see you all here. This is the final event in ME72. It's not the final exam. There is no final exam per se. This is a chance for the students to show off all the wonderful work they've done through the year, as opposed to being examined on how well they perform in this contest. The purpose of the class is to acquaint students with solving open-ended problems. Ones that I think of as being real world in the sense that there isn't a right answer at the end of the book. There's no textbook you can look up the right answer to this problem. We give them a problem of the kind that you'd expect to see in the real world, where you have to accomplish some task and it's not clear how to get there, how to solve the problem. That's what design, and in fact a central portion of engineering, is all about, and that's what this class focuses on. We teach a bunch of design methods, how to solve design problems, as well as conventional mechanical engineering things, machine design, bearings, gears, shafts. So we acquaint students with the basic building blocks of their design, but then they have to synthesize that information plus what they've learned in the rest of their classes in order to come up with a final solution. And you'll see those in just a few minutes. A little bit more background: the students get 10 weeks. That's the total amount of time they have. In the industrial world, that's a fantastically short amount of time to even come up with a first prototype, which is effectively what these students have done. They work in teams this year, and they did last year too, and that's a bit of a change from previous years. The teaming works in the following way. Each student gets a kit of materials, and each student's materials are identical. So they get a bunch of round stuff of all sorts. There's some doweling, gears of all sorts, some rollers, some springs on the right, some more springs down in the lower center. Some of the Toro parts are appearing on the left there on top of a square of nylon fabric. All kinds of strange little parts that we can find at surplus places. Some giant motors that have just come in from the left-hand edge, then plus some smaller 12-volt motors. A bunch of brass tubing, some aluminum, fairly big size aluminum. The black stuff in the middle is heat shrink tubing. The long diagonal pieces of niche and blind. You've seen a number of people have used those. They work together in teams in the sense that two people share a volume constraint, share a weight constraint, and of course the two work together to accomplish the task. Okay? The task is a competitive one, and it's different each year. This year it's completely different, and I'll explain to you a little bit about what this job is for this year. There's a table, okay, and if we could get the overhead view of this, that might help a little bit. And on the table at the start are 8, actually 9, scoreable items, okay, and they come in 3 different geometries. There are cubes, 4 cubes, 4 tetrahedra and 1 sphere. Okay? And these have black stuff on them, as you can see, and it mates with what's here. There's a vertical back wall. The back wall is Velcro loops. Okay? And what's in the black patches on these are Velcro areas. So the objective is to stick scoreable items onto your team's side of the wall. So if this team starts here, this is their side of the wall. Now, how do you score? Well, the lowly cube is worth 1 point. Okay? And sticking the cube in an area multiplies the value of the area times the point count of the cube. So this is the 1 zone, 2 zone, 3 zone, 4 zone. So a cube in that area would count as 1 point for that team. In this place, it would be worth 2. Okay? A tetrahedron is worth 2 because it's harder to get a hold of. It's not rectangular. So that would be worth 2. That would be worth 4. Okay? The sphere is worth -4. Okay? Now, what sort of time do they get? Well, they get 30 seconds of electrical power, which is being counted down here, and so those are the lights in the green zone, and then there's 5 seconds of settling when there's no electrical power applied, and they get joysticks and switches to control the 4 channels of electrical power. If we do our job well as instructors, then the contest will result in many different design alternatives. So it won't all look the same, like an arm that lifts things up, although you'll see lots of those. Or a machine that crawls up the Velcro wall, you'll see lots of those. Or other kinds of machines that have different approaches to solving the problem. We have a short videotape, which I'd like to roll, of the contest devices. This gives you a chance to see the individual machines because they're hard to see during the contest. The students' devices are identified by name, so you can see the individual people. You'll get to know those names better if you don't already know these people. Number 20 there, Greg Fricke's, is a scissors jack that rises up. The placebo is not an active device. That's used when we have a buy. It's a walking machine. It's really elegant. There's a conveyor belt going by from Lisa. Regina's is a very interesting design with some duck feet, as she named them. Andy's has an arm that puts things up on the wall, etc. You get an idea. Brian's is another scissors machine, but of a bit different and very innovative type. Jason's here is quite defensive. He puts up a strip that makes it hard for the wall climbers to climb up over. Anna's climbs the wall very ably, as does Chris's that just went by. Jim and Sue Ann have a tightly knit combination here of defensive machines and a scoring scissors jack that goes up. So you'll see those machines and get to know them much better as the afternoon goes on. Okay, so with this, we're now ready to compete. And so the initial pairing of competitors has been computed by the computer, which will be keeping track of who won and who lost. I didn't mention that it's a triple elimination tournament, which helps reduce the effect of luck. The teams are in the tournament until they've lost twice. So on the near side of that table are Regina Chung and Dale Parks, and on the far side are Russ Howe and Lisa Hung. Ladies and gentlemen, ready, set, go. Oh, come on. Oh. There's still time. Fabulous. Now, that gives you some appreciation for just how hard this is. That there's, there's 2 points scored up on the wall there after 30 seconds. 4 machines fighting it out. Brian, Ethan, Chris, George, ready, set, go. Oh, man. I don't know. Oh, just in case. Yeah, go get it, go get it. Oh, no! Oh, no! Oh. Okay, Suan, Jim, Sue, Andy, ready, set, go. Oh, man. Yeah. Oh, beautiful. Oh. Now. Okay. Liz and Greg, Matt, Jason, ready, set, go. All right, ready, set, go. Oh, yeah. No, it's all over but the shouting, right? Come on. Oh, no. Come on, Chris. Oh. Oh, no! Well, the rule is that you've got to score at least one positive point, or else the round counts as a loss. Okay. Ready, set, go. So Greg and Liz on this side, and Lisa and Russ on the far side. Ready, set, go. Oh, look at that. Look at that. Oh, man. Out of my way. Woo! Woo! So Dave and Steve on the far side, and Brian and Ifan on this side. One loss to no losses. Okay? Ready? Set, go. Oh, I'm sorry. So Corey and Greg, Chris and George. Ready, set, go. Come on, Greg, get that stuck up there. Oh! Come on. Something up on the wall. There you go. Deliver that. Deliver that. Oh, no! Yeah! Oh, as close as you could want it. Too bad. Yep, Chris and George. Okay, ready, set, go. Come on, yeah! Oh, no! Oh! So Anna and Jackie. Okay, gentlemen, ready, set, go. Oh, dead machine already. Uh-oh, uh-oh, uh-oh. I can work just as well upside down. No! Oh! Come on! Stick it! Yeah! All right, ready, set, go. Oh, slicing through the crowd. Come on, Anna. Ah. Oh. Oh, come on, deliver that thing, deliver that thing. Oh! Did it really? Unbelievable. Not many left here. Okay, so Dave and Steve versus Anna and Jackie. Let's rock and roll. Yeah, the judge is just conferring with me, and she's absolutely right that Anna and Jackie have accumulated 2 losses, and the team on the other side of Dave and Steve have a 0. Come on, Anna. Come on, Jackie. Ready, set, go. Belts are flying. Oh, it's ugly. Look at him. Look at him. Come on up, come on up, come on up, all of you, all of you. So, I want to thank the whole class for the outstanding job they did this year, and thank you all for coming to join us. guys all did a great job, all of you. Congratulations. Congratulations. Well, thanks for coming. Thank you all.
I want to play the placebo. I want to see if we can do this.